Hello, this is the final presentation of our Running App project. First of all, is the sampling that we get. We got two kinds of data from the mobile. One is the acceleration on 3 axes. This is to count the steps that the person take. The other one is the position of the person on Earth, which means the longitude and latitude. This one is for finding the distance traveled by the person. Both of the data sets are sampled at sampling rate 10 sample per second. However, when we are collecting data for tests, we find MATLAB hard to operate. Therefore, we downloaded another app to collect data. And we also downloaded an app to count steps for measuring accuracy. The expectation and reality is very different from what we think. In reality, when a person changes from walking to running, the data needs to be modified before being used to calculate steps in our method. In the next slide, we're going to talk about how we calculate the steps taken.
Here is the theory that we use to calculate the first step. First, we find the scale of the dose x, y, z data. Then we use MEN function to eliminate the gravity effect. Then we use STT function to eliminate the noise of the signal. Finally, we use FINDPEAKS and NUMEL function to get the result of the foot step. About the error and improvement, we find that we will get the wrong result with the user are running and walking in the same time, because the walking signal will be the noise, then the signal will be eliminated. By input this situation, we should determine the speed before calculating those values. And here is the data we actually get and the comparisons of another apps. 93 is the another apps and 89 is what we get. Here is the running step and here is the walking state.
This slide shown now is the picture for the theory of Haversine. This is the theory that we use to calculate the distance by using the value of the longitude and latitude. R is the K unit for the distance calculated. Degree to radian. To radian function is used to find the Haversine equation. Arctangent to x, y function is the arctangent of x divided by y. The code below shows how we use to find the total running distance. Firstly, we accumulate the value get by using the Haversine function and count the distance. By using the GPS position, latitude and longitude value, we found out since the distance is very short, the GPS cannot detect the accurate movement, and this causes a slightly long period of time for the position to be received and changed. In this project, we did not use the data of altitude to calculate the total distance. So when hiking or moving uphill, we cannot get the most accurate total distance. This is the last slide. This is the final result of our running app project. On the left hand side is the result of the sampling working data, which calculated 100% accurate result with 66 steps and a total distance of 26.6205 meters. On the right hand side is the result of the sampling running data, which is not as accurate as the working sampling data. The result is 89 steps over the reality of 93 steps, and the total distance of 69.8036 meters. This is the end of our presentation. Thank you. OK，怎么管？